Assalamualaikum and very good morning to my beloved lecturer. So today I will explain about HAZOP study on VCM distillation column, and for your information our group was assigned for this distillation column C202. So basically on the HAZOP study we have many study notes. The first one is stream 13, which is the inlet. Next one is distillation column to C202. So for the stream 13, our process parameter will be the flow. And for the distillation column, our process parameter will be temperature, pressure, level, reboiler, and condenser. And the label for reboiler will be E202, and for the condenser will be E203. And as you can see, we have study notes, process parameter, guides word, which is no, more, less. Sometimes it will be no, high or lower, depends on the condition. Next is deviation, which is related to the guide word, and the next one will be cause and consequences. So for example, for the stream 13, if no flow on the stream, the cause will be the failure of pump P101 to supply water, and the effect will be no separation process occur in the distillation column. And as you can see, we have solution for that particular problem, which is our solution will be the action, and our action will be emergency shutdown and install pressure relief valve. So for the temperature, basically everything is related to the heating process. And if, okay, for example, for the high temperature, if temperature is too high, explosion might occur due to very high temperature. What is the cause for this problem? Because the flow rate of inlet from stream 13 is too low. So basically the water inside will be very low and it will become very hot immediately. And what should we do? We should install high temperature alarm, which is called as TAH. For the pressure, what happens if the pressure is too high? Same with temperature. If pressure is too high, explosion will occur. Boom. So what's the cause for this problem? Because the column temperature is too high, and to solve this problem, our action will be automatic shutdown for the process plant. Next, for the level, we have high level and low level. So for the high level, okay, if the outlet flow rate is too low compared to inlet flow rate, the tank will be overflowing. So to solve this problem, we need to install high level alarm, so we can detect if the water level exceed that particular level. So next one is reboiler E202. We have yes, no, or less. No or less stands for is related to the heat supply. If no heat supply, it will be very low efficiency of separation occur at the bottom product. So in order to solve this matter, proper maintenance and inspection need to be done regularly. And last one will be the condenser. For example, okay, condenser will be, we will have no or less. No or less is stands for no cold water supply and less cold water supply to chill the stream. So for example, if no cold water supply at all, what's the main cause of it? It will be the blockage at the cold water storage tank. And what is the consequences of this problem? The top product will be very hot. So in order to prevent this problem, regular inspection and maintenance on the top stream, so we can identify if the top product is very hot, so we can solve it. So as a result, we can get a better product, better top product. So that's it for me. Thank you and have a nice day.
I'll be explaining about the results and discussion that we have obtained from the research that we have conducted for this project. Firstly, we did a hazard analysis on the C202 distillation column and found that the study notes that we have used is stream 13 and distillation column, which is C202. For stream 13, the process parameter is the flow, and the cause, consequences, and action is listed in the table as shown, while for the distillation column, the process parameters involved are temperature, pressure, level, reboiler, which is E202, and condenser E203, with the cause, consequences, and action, proper preventive action stated in the table as shown. Followed by that, a consequence study on the C202 VCM distillation was done. From in the distillation column, there is top product and bottom product. The top product is VCM, which comes out as vapor, and the bottom product is EDC, which comes out as liquid. For the consequence study, we did 3 possible consequences, which is liquid or vapor flow through a hole, downwind vapor concentration of VCM, and radiant heat flux of VCM vapor. For liquid or vapor flow through a hole, based on the graph plotted, we can see that the mass flow rate of EDC is higher than VCM, as well as the total quantity released by EDC is higher than VCM. From this, we can conclude that the flow rate of EDC is higher compared to VCM, therefore more EDC will be released compared to VCM at in a period of 90 minutes. The hole size for this is 4 inches for both. Followed by that is the downwind vapor concentration of VCM experiment. For this, we conducted a research on by manipulating the distance starting with 20 meters, then 500 meters and 1000 meters. And from this, it is observed that for 20 meters and 500 meters, the percentage of fatalities is 100%, and for the 1000 meter distance, the percentage of fatalities is 99%. From this, we can conclude that the further the distance between the release point and the community or the employees, the dispersion of VCM is greater, therefore the toxic material release becomes diluted, resulting in lesser number of deaths. Finally, for the consequent study of radiant heat flux of VCM vapor, the same thing was done, where we manipulated the distance to see the difference and the percentage of fatalities. We use a distance of 20 meters, 500 meters and 1000 meters, and from this we can deduce that the highest Q value, which is the highest incident thermal radiation, is at 20 meters, and for 500 meters and 1000 meters they are very low. However, for all 3 distance, even with high Q value for distance of 20 meter, there was 0% of fatalities. For this, theoretically, thermal radiation is inversely proportional to the distance from the midpoint of the flame, and a fire can only start when all 3 resources, which is fire, heat and oxygen, are available. This also relates to the flash point temperature of the substance, where flash point is the minimum temperature at which a liquid gives off enough vapor to form an ignitable mixture with air. The flash point of VCM is negative 78 degrees Celsius, and it is lower compared to EDC. Therefore, we can conclude that VCM is more flammable compared to EDC. That's all.
Hi, I'm Nur Hidayah, and I will be presenting about mitigation strategies to minimize the risk. So VCM needs to avoid from temperature more than 400 degrees Celsius. This is because elevated temperature can cause VCM to decompose, which will release toxic gas, which is is actually dangerous for us. And then VCM is also an extremely flammable vapor and liquid, which ignition and flashback can occur due to that. And then, so in order to prevent that thing, all the equipment need to be electrically ground and bond, and the contact with air, which is oxygen, moist air, strong oxidizer, and metals need to be VCM need to be avoided from this thing. So next, another mitigation strategies to minimize the risk of VCM is by using hierarchy of control. As we can see here, the top one is elimination, which is the most effective in the hierarchy of control, while the least effective is the PPE, which is personal protective equipment. So when we say about elimination, what it means, like physically remove the hazard. But then due to this case, we can't physically remove VCM since it's the main product of the whole plant. However, for the second one is the substitution, which replace the hazard. So as we can observe now, VCM is actually a very dangerous, very flammable and dangerous thing. But then if we substitute it to the other liquid, we need to do a longer research and study, and at the same time that produce the same quality of PVC that we want. Okay, for the third hierarchy of control is actually engineering control. Engineering control such as enclosure, the point of release, and local exhaust ventilation. However, the engineering control does not eliminate the hazard, but it will isolate people from the hazard. So for the fourth one is actually administrative control. Administrative control only is actually change the way that people work. For example, changing of procedures, employee training, installation of signs and warning around the plant. And actually safety policies such as standard operating procedure, which is SOP, should be provided in order to achieve the goal of reducing duration, frequency, and also severity of the exposure. And administrative control also does not remove the hazard, but it will limit or prevent people exposure to the hazard. And lastly, the least effective hierarchy of control is to protect the worker with personal protective equipment, which is PPE. So for the example of PPE is glove, uniform, respirators, hard hat, safety glasses, high visibility clothing, and also safety footwear. However, PPE is considered as the least effective way in the hierarchy of control. So as we can see here, we can use hierarchy of control as one of the mitigation to minimize the risk.